Welcome back, Transatlantic AI hackers. This is Jay Burris, your OpenVINO Academic Program Manager, and Eric Kolkaj, your Depth AI software developer from Luxonis. Reminder, we're bringing you 3 exciting collaborative AI-capable technologies. Today's training video is about the Intel Developer Cloud. It's always installed with the latest version of OpenVINO Toolkit. You can do active learning through Jupyter Notebook tutorials, and you get up to 50 gigabytes of private storage space for your code and your data sets. So let's get practical and actionable on the Intel Developer Cloud. Let's talk a bit about how the Intel Developer Cloud works. So number 1, it's an instant AI inference lab for your projects. There's no fees required, there's no budget, shipping, setup, maintenance, or upgrade expenses required. It's too expensive now with all the proliferation of all the different types of hardware available for really any one person to develop their own lab. You have access to a lab instantaneously with a whole range of equipment. You can learn OpenVINO Jupyter Notebooks from tutorials and real-world sample applications. You can prototype on this latest hardware and software, and you get up to 50 gigabytes of private storage space for your data sets and your code. And you can also benchmark your customized AI applications with immediate feedback on frames per second performance. So let's talk a little bit about the diagram. Starting with number 1, this is you, the developer, logging in securely to the Intel Developer Cloud. And you're logging into development servers, the little number 2 there. And hosted on the development servers is the Jupyter Lab environment with all the Jupyter notebooks, as well as a couple other tools, the model visualizer, and deep learning workbench. You can also download from GitHub, such as from OpenModelZoo, all the range of models that are available to you, which was previously discussed in the last training session. You can upload your own data sets. You can download your own data sets. You can upload your own video streams and your images. Now, how do you develop and execute on the Dev Cloud? Well, you develop in your own 50 gigabytes of private storage space on the storage server, and then you execute to a job queue, and you can execute simultaneously to a number of different devices, and you can compare the results. So you can execute to systems that have CPUs with integrated GPUs or just CPUs. You could execute to equipment that has VPUs, for example, and you're performing the inference on your video and your images. And then you can analyze the output and the results and the performance with the telemetry dashboard. Let's take a stroll to the Intel Developer Cloud. It's very easy to reach the Intel Developer Cloud. You can type in devcloud.intel.com. And now we're on the main landing page for the Intel Developer Cloud before even signing in. There are 2 halves to the Intel Developer Cloud. Here on the left side is the half with the OpenVINO Toolkit and some instruction on Jupyter Notebook tutorials, how you can build your solution in the Jupyter Lab environment on bare metal, or you can launch in a containerized solution. Here on the right side is Intel's One API tool suite for software development for things like high performance computing, SYCL C++ for the next generation of heterogeneous computing programming, AI analytics toolkit, rendering, and more. I'm going to go into the left side for the Intel distribution of OpenVINO Toolkit. Now I'm on the main landing page for the Intel Developer Cloud for the Edge. This is the side with OpenVINO installed and all of the edge hardware that you need to have access to. Now, there's a helpful video tutorial here that you could watch. My colleague, Meghna, will describe what the Dev Cloud offers you, how to use it, and so forth. Now, there's 2 ways to do development in the Dev Cloud. We're going to focus on one in this video, but there are 2 ways. Number 1 is bare metal development with the Jupyter environment. Number 2 is a containerized development environment powered by Red Hat OpenShift. I'm going to focus on the bare metal development side with Jupyter. But first, I want to show you a few other things. There's always a latest announcements section here that you can follow. additional developer solutions that you can learn about. But here's something really exciting. So you can explore all the edge hardware available in this dev cloud that you can execute jobs to. So let's go in there. Here's provided a list of edge nodes for the bare metal workloads. We call them edge nodes because this is physically edge hardware that you can access to run your jobs to. And this provides you a lengthy list of all the different types of hardware that are available. I'm going to expand it now, but showing you the first line, for example, shows you that there's an edge node with an Intel Core i9 13900 Ti processor. Contains 32 gigabytes of memory and integrated graphics capability. It does not contain an Intel accelerator. Others down below in this list do. And then there's a job queue label and a node ID, which is information that you'll need to know in terms of performing a job to execute to the queue. Now there's a couple other examples. Here's an example here with a discrete GPU available and below it as well. Many of these systems have integrated GPUs, meaning a GPU that's inside of the CPU. These two rows have an Intel Xeon processor along with a discrete GPU, an Intel Data Center GPU Flex 170 and a Flex 140. Further down, we'll start to see some examples where there's an accelerator additionally. So this edge node is a Core i5 6500 Ti processor, and it comes with an integrated graphics inside the CPU, but also these accelerators. So here is an example with 8 Movidius MyriadX VPUs. To put that into some context, the device that we're shipping you from Luxonis, the Oak D-Lite, a very small device, has 1 VPU in it. We have customers who create daughter cards, add-in cards, with up to 8 VPUs that slot into PCI Express and other form factors next to CPUs in such a system like an edge server. Here's one with an accelerator of an FPGA. Here's another with an accelerator of just 1 MyriadX VPU. Now let's log in. Let's get started. Get our hands dirty. So I'm going to go to the bare metal development and press get started. And immediately a Jupyter Lab environment will begin to kick off. Now what you'll see is you'll see a section here to the left of all your files, and you'll also see a number of Jupyter notebooks that are available to you. So you could learn about using the DL Workbench. It's a GUI-based tool that allows you to quantize and benchmark and compare the performance of your model. There are more starter-like Jupyter notebooks like object detection, learning about the code snippets. That's also a great way to start. Code snippets are over here available on the left side. This little sort of caret/caret allows you to insert code snippets into your own Jupyter notebook. And if you were to start your own Jupyter notebook, such as File, New, Notebook, you choose a kernel. What I recommend choosing is the latest one, 2022.3. And you're immediately provided a way to insert code. You could actually also insert Markdown or RAW, but in this case we'll do code. And we'll just choose any one of these code snippets. So I could insert the code snippet, and voila. This code snippet is providing all the sort of OpenVINO dependency libraries, such as matplotlib, the OS, time, all for Python. Now let's go back to the home in Launcher. There's other Jupyter notebooks here, such as classification. You'll find that's very similar to the Jupyter notebook on GitHub for classification. There's a Jupyter notebook on how to download to edge migration, essentially how to get data from the dev cloud down to your PC. And there's a corresponding tutorial on how to migrate data from your PC up to the dev cloud. And there's a whole bunch of others. You can expand the Jupyter notebooks and explore things like noise suppression or yellow V4, really maybe more focused on specific reference implementations like restricted zone notifier, where in the images, in the stream of video and the images, people come into frame and it's identified that people have come into a frame and they may not be in a area where they should be, that maybe not be safe around mechanical equipment or something like that. You could also explore brain tumor, shopper gaze monitoring, and many more. So let's get started with one, and we'll start with the classification tutorial. So I'm going to press on it and get started, and you can see now this is very, very similar to the Jupyter Notebook on GitHub as well that you can install. And these Jupyter Notebooks are great because they're all this written narrative that teach you the concepts of using OpenVINO and the concepts of using AI computer vision surrounding executable code a little further below. And you'll get to these executable code blocks like these in the dark gray sections where you can actually run them. But let's go back up to the top and walk you through quickly this Jupyter Notebook. So this Jupyter Notebook is this IPYNB file, this tutorial classification sample, and that's stored over here. We're also providing the .xml, the intermediate representation file, and we're providing the labels file as well that categorizes all the different types of objects that are able to be classified by the model that's been provided, this SqueezeNet 1.1 model. We're also providing you images for a dog, a cat, and a bird, and some images in the documentation as well. Now this tutorial is going to walk you through the basic concepts of OpenVINO, the terminology, how OpenVINO provides the model optimizer, which converts a trained model to the .xml and .bin intermediate representation, and then the inference engine, so applying the API into an application that corresponds to your larger user application that needs that AI inference. This model will then explain and walk you through this Jupyter Notebook about how you load the plugin, you read the model IR, you load the model into the plugin, prepare the input, run the inference, and then process the output. It'll also teach you a bit about frame resizing, transposing, and reshaping, because in our previous training video explained that models have been developed and expect the input, the image frames, and the video to be in a certain size. Remember, a video is just a string of images strung together. So you may need to resize and transpose and reshape your images to fit according to the specifications of the model. Now, each of these is the executable sections in this sort of like dark gray boxes. And in this section, we're importing the standard libraries for OS and Open CV library, Time, NumPy. The OpenVINO inference engine library itself is imported, and matplotlib. Now to run these, you just press run, and it printed out that it imported the Python module successfully. The next section is a section on creating IR files, and you can actually download your raw models. If you uncomment this, and run it, it will start to download all the raw models. And it'll take a few minutes because we're actually downloading this SqueezeNet model here. If you wanted to add -- print all, it wouldn't download, but it would print the list of available models of which you could download, and then you could edit your code to be the specific model that you wanted by -- name and the model name. In this next section, we're actually converting the model to the IR format. That's what OMZ Converter does. So we'll run that. And now it's converting this this SqueezeNet model. It was originally a cafe model. The data type is specified, the output directory, and some additional information that you might need to know, like the input shapes, batch, and how many channels, 3 RGB, and the size of images needed, 227 by 227. Now scrolling down further, we get to a section that describes the model paths for the XML, the bin, the input path, the device, and so forth. And in this section, it's been predefined with that. Our model XML is located in the model directory, public, SqueezeNet 1.1, an FP32 size, SqueezeNet 1.1.xml, and .bin. The input path for the image is the dog JPG. So these files are over here in your directory structure. The CPU extension, the device we're setting to run it on CPU, we're running it on the development servers here, and then we'll print out some information and parameters. So we'll run this section and it'll print out the parameters that we've set. Now we're instantiating the inference engine. So we're starting up the inference engine core, and it's been created, and we're going to create the network. So we're going to load the model, or the network model, the XML and the .bin file, to net. And we're going to check on supported layers, because neural networks are created with multiple layers in them. It'll define and say if there is a layer in this particular model that is not supported. So we'll click on this section and run it, and we've had success. Now we're going to load the model with the IE load instruction and load it into ExecNet. Now we've printed out the model input dimensions, batch size of 1, there's 3 channels, and the height and width is 227 by 227. We're going to load the labels file that labels all of the 1,000 different types of objects that are classified by this model. Now we're going to prepare the inputs by doing some resizing and rearranging of the dimensions so that we can import the image correctly. Now the image that we've used is this image of the dog. A little further up, we plotted the image, converted it, and plotted it and printed it out on screen. Now we're going to get to the run inference section. We're going to start the inference. We're going to start the time because we want to measure how many frames per second it does so we can measure performance. Inference was completed and runtime was 18.413 milliseconds. Now we get down to a section where we're going to process the display results. Now, it has accurately identified this dog as a probability of 23.296699% as a Chihuahua. Could be a Chihuahua, could also be a Husky. That's kind of why the results show Husky is also second likely in probability. And all of this code here has been written to process the inference and print out the results of the highest likely probabilities. Now you can run your own images as well. You can run this one on cat, or you can upload your own images to your directory structure and change the image path to whatever image you want. You could run optionally an image from a other path that you can access, perhaps on the web. And you can also prepare batches of images to run, such as dog, cat, and bird. And that's this tutorial for classification. Thank you for watching this review of the Intel Developer Cloud. So number one, try out the Intel Developer Cloud for the Edge and the Jupyter notebooks that are in there. Go to devcloud.intel.com/edge. Number 2, try out our Jupyter Notebooks on GitHub as well. And number 3, explore Luxonis' Depth AI resources, their documentation, their own GitHub repository, and their Discord community. We look forward to your creative solutions. Thank you.